Solving equations, proportions, and word problems. A proportion is made up of two blank or fractions. Another word for fractions is ratios. Set equal to each other. While the rules for solving proportions are the blank as all other equations, well, they're the same as all other equations. Many people have a hard time with them. Let's look at example 1. We're going to solve for x and then check. When solving a proportion, it's really just the same as a regular equation. We see here that we have x divided by 2. Well, to isolate x, we multiply by 2 because right now it's divided by 2. The inverse of division is multiplication. So we multiply by 2. Multiplying by 2 is the same as multiplying by 2 over 1. And it's sometimes easier to see a fraction multiplied by another fraction, remembering that we multiply across the numerators and across the denominators. On the left-hand side, we've isolated x, and on the right-hand side, we have 6 times 2, that's 12, over 3 times 1, that's 3. So we have 12 over 3. But 12 over 3 is just 4. So we've solved for x, we've isolated it and found that x is equal to 4. Now we can plug it back in to check. So we are going to do 4 over 2 is equal to 6 over 3. Well, on the left-hand side, 4 divided by 2, that's 2. And on the right-hand side, 6 divided by 3, that's also 2, and it checks. We've done a great job on our solving. Right. Now, in example 1, the unknown value was in the blank of the fraction. Oh, the unknown value was in the top, so that is the numerator of the fraction. The top of the fraction is called the numerator. Sometimes it is in the, well, if it's not the numerator, then it's in the denominator, the bottom of the fraction. When that is the case, the same solving rules apply, but these kinds of problems do cause difficulty for some people. Let's have a look at example 2. We're going to solve and check again. So now here, we're going to do the same thing, but first we're going to have to multiply both sides by x, or x over 1, same thing. On the left, we've got 6, that's all that's left. And on the right, multiplying across the numerators and the denominators, we have 3x over 7. 3 times x is 3x, 7 times 1 is 7. Now our next step is to get this 3x term by itself. Well, right now it's being divided by 7. The inverse operation of dividing by 7 is multiplying by 7. So we multiply both sides by 7. 7 times 6 is 42. And over here, this 7 and 7 make a 1, so we're just left with 3x. Now, our next step is to isolate x. Right now, it's multiplied by 3, so we're going to divide by 3. When we divide by 3, on the right, we have x, and 42 divided by 3 is 14. So we have x is equal to 14. Now we can plug our answer, 14, back into the equation. So we have 6 over 14 is equal to 3 over 7. Well, there are a couple ways to see that this is true. We could just do 6 divided by 14 in our calculator and 3 divided by 7 in our calculator. And I think that's probably the easiest way to do this. So let's pull up a calculator here, at least the face of it, so you can see the work that I'm doing. And we'll do 6 divided by 14. And that is about 0.42857. So let's just say 0.4286, and that's an estimate. And now we can also do 3 divided by 7. And it's important that we see that those two are exactly the same, 0.4286. Those two numbers are exactly the same, and that's really important. The other way that we can see that the two fraction, oh, whoops, sorry, I didn't see it, didn't notice you couldn't see that. Sorry about that. So the other way that we could have seen that these two fractions are equal to each other is to notice that 6 and 14 are both divisible by 2. And so when I divide 6 by 2, I get 3. And when I divide 14 by 2, I get 7. And so that's another way to see that our solution um, is correct. All right. When solving many word problems, you must write and solve a proportion. Follow the same steps that you do for other word problems. And I'm not going to read those steps, but as we're going through the word problems, we will do them one by one. Step 1. Your car can drive 50 miles on 3 gallons of gas. How far can it drive on 9 gallons? Now, it's important that when we are thinking about this, we have read the problem first, don't do anything. Next, we'll define the variables. So we'll use the variable, how about just x for equals number of miles my car can drive on 9 gallons. So that's exactly what we're looking for. When we think about miles and gallons and cars, we have to use something that we hopefully know about the equation, and that's this idea of miles per gallon. Now, miles per gallon has this key word in it, per, which means we're talking about a fraction. So it's, it's miles divided by 1 gallon. And so we're talking about division here. So this can help us to see that we're going to set up a proportion. We know that we can drive 50 miles on 3 gallons. And what we want to know is how many miles we can drive, that's x, on 9 gallons. And so I'm going to move these out of the way a little bit. Sorry that I am making some adjustments here. But we're setting up this proportion, 50 over 3 is equal to x over 9. Now, something interesting happens when we solve this particular proportion. To get x by itself, we multiply by 9. But when we multiply by 9, on the left-hand side, we get 450 over 3, and on the right-hand side, we get x. 450 divided by 3 is 150. It's easy like that. It just comes out to 150. So now we've written the equation, which was a proportion. We've solved the equation, and now we need to answer in a complete sentence. So the question was, how far can it drive on 9 gallons? My car can drive 150 miles on 9 gallons of gas. And I am recognizing that I am covering that up right now and you can't see it. Again, I'm so sorry about that. So there you go. When I solved, I may have gotten here and thought, geez, I don't know what that 150 means. But if I look back to how I defined it, it is the number of miles that my car can drive on 9 gallons. So my car can drive 150 miles on 9 gallons of gas. So that is how we can use proportions to solve some linear word problems.